Hello community! Hey, we have a beautiful new paper today and we talk about January 10, 2025 about a new publication from MIT, from Harvard University, from Stanford University and from Google DeepMind. Couldn't it be any better? And we will talk about LLM self-improvements, and we have our beloved chain of thoughts implementation, and yes, we are working on a multi-agent platform. I mean, couldn't it get any better? But let's first understand the problem we're dealing with, and we have here an issue here with decreased gains that we get here in the performance benchmark and the performance data after multiple rounds of fine-tuning our LLM or our agent or agentic system. We have now here these problems of the decreased gains here in the performance. And I would like to enter this topic here with analogon. What we humans do. Now we have a team members, similar base level of knowledge, great, and they have a discussion, they exchange here their ideas, they argue back and forth, and maybe you have a boss, and you know a boss is always helpful, now it provides feedback so you can have a better knowledge improvement and whatsoever, and then the result is the whole group has created some new knowledge, maybe each and every single person has here a particular set of new information, of new insights that adds now to the body of knowledge of this particular person, and this is the process. And guess what? If you look at the core of this paper, this is exactly the process, the procedure we're gonna implement now. Just maybe before we do it, I would recommend you read this paper here. This is already from May 2023, but it is really here a significant paper. Improving factuality and reasoning and language models through a multi-agent debate. As you see, MIT and Google, beautiful. This is here more than 1.5 years old. And yeah, this is exactly where this branch started, if you want. So the authors tell us here, hey, our method fine-tunes now a multi-agent set of particular language model, also small language model, from the same base model, and then independently specialized each model to capture part of task of interest. And they say the key insight is that by fine-tuning now multiple models, we can encourage the specialization and diversification across the responses of the group, which can enable consistent performance gains over many rounds of fine-tuning. So is this the solution to our problem that we encounter? But you see here, many rounds of fine-tuning indicates here some heavy workload on your computer infrastructure. So let's have a more detailed look. Yeah, the role of the boss can be, of course, in the simplest implementation, he critiques now the statement here by each single person, or, which is much nicer, I like to implement this much more, is the prompt, hey, can you derive a new solution by combining your solution here with the solution of the other agents? So here we have a real helpful boss that integrates here the responses from all his team members and then comes to a conclusion that is gaining some insights for individual members. So you have more of a cooperative setting, but if you like to have a boss that is strong and critiques, or if your boss that is helpful here, you can go with both solutions. So let's look at this now. And this is now the agent. This is, you see, it's absolutely symmetrical. Here we have 5 people. Here we have 5 AI agents. And we start with identical base models. They have all the same knowledge, the same set of training. Now, the boss, of course, is here also an AI agent. You can do this also, that this is here just the 6th copy of this, or you have here maybe a little bit more powerful, more insight, maybe a domain-specific trained agent, as you like. And then we have this discussion, these bubbles come up, and then the boss maybe is some brilliant ideas, you know, all the ideas come only from the boss down to the people, and then we create a data set. And with this data set, we have now the classical Hugging Face supervised fine-tuning approach, and then we fine-tune with this data set. This is the data set, the bubbles of all ideas is now here a supervised fine-tuning happening. And to be clear, if it is a more complex topic here, they say we introduce here a summarization agent. So just here, for the critique here, it helps if you summarize here, if you integrate here from those 5 AI agents, you really try to get every idea or every information from each and every agent. So the summarization agent maybe is a good idea before you have the critique agent, or maybe you can integrate them into one you see, you have a lot of possibility how you build your multi-agent system. And some weeks ago, I showed you here the small agent from Hugging Face. What a beautiful, easy code implementation for this. Okay. Now, just want to understand, also they found it is helpful if there's also a supervised fine-tuning based off the level of the discussion of our boss agent, of our critique agent, of our cooperative agent. So more or less every agent with the continuation here of this discussion process will be fine-tuned. And this is a lot of fine-tuning. So the role of the critique LLM, this is this one here, which evaluates and refines the responses of the other agents. And the multi-round debate here, this is the start where it all started. And if you then go upward here, time indicates here time passed. Now we have the creation of a unique data set based on the responses of all these agents, based on the critique of the boss agent. So for each agent, you can now distill, if you want, a unique training data set based on their individual responses of the past and the critique evaluation by the boss agent. Now you somehow, if this agent was focusing here on HR, human resources, and this agent was here focusing on technology, you can now say, okay, so from the new training data set, I use only a particular part here of the complete training data set, and I do here, I start with a specialization fine-tuning, a supervised fine-tuning here on this particular data set. So you see, the idea is now to start here from identical humans or AI agents, and given the process of discussion, we see maybe only by statistical, alterations, we can now start here the specialization for each and every agent. To show you here the first results. Here you have now for the Phi 3 model or the Mistral model or the Llama 3 8B model, so rather small language model here, their performance or their accuracy, and you see here the iteration of fine-tuning. If you have multiple fine-tuning steps, this is going to happen. If we only have a single agent in our team and we do the fine-tuning and we have no discussion and no feedback, then you see the single agent just having its own knowledge maybe increase from 50% to 52% and 53%. But then the more fine-tuning we do with the inherent knowledge of the agent itself, it just decreases. We lose performance. The same is happening with Mistral and the same is happening with Llama. However, if we do the multi-agent that we just showed, this team member, each team member, and giving only a statistical fluctuation in the answer, has maybe some new ideas. And so you see, we are now in the position, if we do, and this is done here on a MAD data set, I'll show you this in a minute, this is a known benchmark. If we do this, you see the performance increases. So given that we have a multitude of new ideas, or maybe just statistical fluctuations, at least we can distill new data sets. We fine-tune the model on this new data set. Then those new fine-tuned models produce another new data set. On this new data set, we can do another round of fine-tuning. And so we go fine-tuning after fine-tuning after fine-tuning after fine-tuning. And interestingly, what they show here on this MAT dataset benchmark, they can really go from 57.5% performance accuracy close to 67%. So there's a certain area of improvement. Interesting question, is it limited if we do not add external expertise? Another question, give me a minute. But the fine-tuning process is an essential core element of this whole thing. So at first, we use the multi-agent debate, and if we can go with a majority voting system. If we have 5 agents, beautiful. So if 2 agents say we go with solution A and 3 agents say we go with solution B, you know how you proceed because you have majority voting to create the data set. And then these data sets are used to fine-tune each and every single agent. The generation agents are 5 agents at the bottom, and the critique agent, the boss agent. And when the fine-tuning generation models, here we use the majority voting or whatever, and the critique model, maybe it's a little bit more sensitive depending on your particular domain knowledge, uses the responses from the final round based on whether responses match the majority vote. You have a mix of correct and incorrect input. So this is here a real sensitive topic, but also which model you choose here. So let's look at the process here in this beautiful pseudocode. So we have here a multi-agent fine-tuning procedure. And to help you, you see that's rather easy here. This is here the block here of the debate, all the agent debate, and have then a summarization of all the responses. And we have a majority voting by our 5 agents here what to do next. And therefore we have now our data set. And if we have the data set, we start here with the multi-agent fine-tuning. You see this is this block here. This is now simply the fine-tuning here of the generation model, the 5 AI agents here, and the critique model, our boss model. And this is it. This is all there is to it. But you know, there are some hidden insights. Yeah, and then of course, after we have done the fine-tuning, of course, like every AI, we want to have here the performance of the AI, the prediction of the AI, we have an inference run. So at the inference time, we have now a set of fine-tuned generation models, beautiful, which represent here the generation agent and a set of fine-tuned critique models. You can have more than one boss model. You can have one boss model that is specialized in human resources and one that is specialized in technology or whatever. You get the idea. Then you have in the inference run a multi-agent debate among those agents, where each individual generation agent participates in the first round, followed by an individual critique agent in the subsequent round. And yeah, you know now how we do this. And then there's the evaluation after the inference round finished. And the team here from MIT, Stanford, Harvard, everybody asks, so how good are we? And they took 3 standard benchmark data for reasoning tasks, the arithmetic, GSM, and math. And here, this is the original authors if you want to check it out. So what they did for each data set, the authors say we randomly selected 500 examples for the fine-tuning, and we kept 500 problems for the evaluation run. So the classical, what we do with LLMs. And this is here now exactly the explanation how we arrive at these results. So for math, 500 were done here for the training, and 500 gives us here the evaluation result, either for a single agent or a multi-agent configuration. But you know, I just had it sorted this, and I said, hey, wait, all these 3 math and everything data set, the benchmark, they are standard data set. They are available for years. No? Maybe a small LLM might already have been pre-trained already on them, and I mean them, the question and the solution. Huh? So what does a value of 54% really tell us? And you may say, what are you talking about, 54%? Yeah, I have to show you this. They argue here, if we take the Mistral small language model, for example, and we only do this particular fine-tuning with the multi-agent configuration I just showed you here, only on the math dataset. And then I evaluate it on the GSM dataset. While the Mistral, in this fine-tuning approach, has never seen the GMS data. How good is it in generalization? And you see here, the Mistral, the base model, has here GSM accuracy on this new dataset, 44%, only trained on the math dataset. And if you have a majority voting, 49%, and if you have a debate, 51%. But of course, here we're interested in this new approach, multi-agent fine-tuning, 54% accuracy. Now, as I told you, I have this question, is this now really an improved multi-agent, multi-step reasoning process that improved? Are we absolutely sure about this? Because think about it. Here in the base model, yes, but we have one run in the inference. So the model is activated here with one GSM task here, and it's run one time. Here, we have the model, and as I told you, we have 5 base model, and they debate and they come up with new ideas and whatever. Let's say we have 10 inference runs. So if I have 10 inference run on this single GSM question, let's say it's only one question, then I get 10 different answers, because maybe I have a variation in the temperature that I put here, my hyperparameters of the LLM a little bit different. You know, I do not get 10 times the absolute identical answer. If I increase the temperature, if I increase a little bit my hyperparameters, I get a variety of answers from the same model. And let's say I have 10 inference runs. And this 10 inference run give me 10 new ideas. And maybe only 1 or 2 is slightly better. So in general, if I do this over 500, I can go in general from 44% to 54%. And if this was already trained, this model on the GSM data, what does this 54% tell us? If we think about, and now I refer to my last video here on grogging and memorization, is this not just because we run the same model 10 times, you know? And then we look at it and we say, hey, now we have a better probability data distribution because we added now to this one run 9 additional runs. So did we gain new knowledge from the identical model? Is this not just a probability data extension, if you want? Is this really an inherent reasoning effect? I don't know. I can't tell you right now, having read the paper now 2 times, I'm not sure about here this particular effect. I would tend that it is maybe also a contribution here for this added probability data if you run it 10 times. But okay, let's go with the official paper by Harvard, MIT, and Stanford. Resources, hardware. What I found here is to say, okay, we use just 4 H100 NVIDIA GPUs and take about 240 gigabyte of GPU memory. And now the important part. The inference run took them between 12 to 24 hours. So just to be sure, we are not talking about the fine-tuning process that we talked about here 80% of the video, no? No, we are now at the inference run. So the inference run takes now all these fine-tuning, multi-agent fine-tuning models here, our 5 generative and our 1 boss model or 2 boss model, that all are already fine-tuned. So let's say if the inference run takes 24 hours for this consortium, let's say we have a multiplicative factor of 10 only for the fine-tuning. So one day, then we need 10 days only to come up with the fine-tuned AI agents that are now the base for the execution here in the inference run that takes 24 hours. And this on a small language model. You see, is this really a new learning effect? And I would say on the one side, yes, because we have this continual fine-tuning. So we really modify here the tensor weight structure in our layer of our transformer. We really run through the complete transform architecture. We really have here an imprint of this new knowledge, no? So it is really then an inherent part of this LLM. So therefore, I would say, yes, this is a real learning effect. But going only with 3 very well-known, very publicly available benchmark data, I'm not sure how to absolutely filter out this component. So maybe you found some further information, but maybe we should look out that there might be a slight perturbance to the system. Let me talk about here what I think are limits of knowledge from within. So what do we have? We have here a group of agents or a group of people. And let's say all these people here have the same knowledge, remember, and they are agricultural technology specialists. They know everything about GPS and agricultural infrastructure. They know everything. If I would give you now the task to explain here the flight dynamic of a fighter jet, how should a group that is in its bubble of knowledge, and they only have the ability to talk to themselves, but they all start from an agricultural expert, and they have not access to new knowledge. What are the limits of their knowledge? Is it only a domain-specific mathematical knowledge that they can achieve, even if they run now for 3 weeks this fine-tuning multi-agent procedure? Because I have a feeling they will never, in their bubble, understand the flight dynamics and the physics of ultrasonic. So what are the limitations of this particular multi-agent fine-tuning process by MIT, Harvard, and Stanford, and Google? So let's come to the end and answer, so what is this paper exactly? What is it focusing on? Because if we start here from a society of agents that are absolutely equal in their knowledge base, and then we are just looking through advanced interaction and critique models and cooperative models to gain here new knowledge, new data set, new fine-tuning procedures, so that each and every agent can start to specialize. It looks a little bit like the evolution of the human civilization. Huh? But why we would do this if we would have already access to expert AI models that are specialized only on a mathematical data set, or only on a philosophical data set, or on a medical data set? Why we would need to investigate this particular model? And I'm here with my question and I say, so what is this? So maybe you have some insights, But I want to be absolutely clear here. This is here now the official conclusion by this team of authors, and they deserve that we show it also what they say, what they achieved. The authors say, hey, we have introduced a novel multi-agent fine-tuning framework that significantly enhances the performance and the diversity of language model. They continue, by employing here a society of agents with distinct roles, our method effectively improves the feedback mechanism and the overall output quality, mitigating the limitations inherent in single agent self-improvement methods. So, a complete different kind of interesting paper this time for you. I almost enjoy designing and preparing this video. Would be interested in your response, and if you think, hey, this could be something, why not subscribe to the channel and you will be surprised what we're gonna talk in my next video.